Hello info person, this is Anton, and today we're going to be discussing a somewhat intriguing and completely unexpected discovery that essentially suggests that the vast majority of stars in various star clusters located in the Milky Way seem to have originated from just three main sources out there. Or basically, three individual locations somewhere in the Milky Way galaxy that seem to be extremely active at producing most of the stars that end up in various clusters. And so let's actually discuss this in a little bit more detail, but first, a very important distinction and I guess definition of different types of star clusters out there. For example, right here you see the famous Pleiades, the Seven Sisters. Probably one of the most iconic clusters out there that's not just the nearest such cluster, but also one of the brightest and one of the best studied. Here's a rough map of this cluster showing us all of the main stars. This is approximately 150 light-years away from planet Earth, with the other famous clusters being the Hyades cluster and the one known as 47 Tucanae. All three of these clusters are visible to the naked eye, and all three are pretty well known. But the thing is, 47 Tucanae is actually very different from the other two. As you can see, it's much brighter, much more massive, contains way more stars, and it's actually an entirely different structure. This is a globular cluster, something that we believe is billions of years old, potentially as old as the entire galaxy, and something that's usually on the outskirts of the galaxy itself. They're almost never in the galactic disk, and that's actually because their origins are still kind of mysterious, but they're believed to be leftovers from ancient galaxies. You can actually check out some of the previous videos on globular clusters exploring their mysteries in one of the videos in the description. But unlike 47 Tucanae, and unlike other globular clusters, these are open clusters. So this is Pleiades, and along with Hyades, they're essentially extremely young objects, and are most likely going to at some point fall apart. And so here we have two completely different clusters. The ancient globular clusters that very likely started when the Milky Way galaxy was still a baby and still growing in size, and open clusters, which are essentially also stars connected by gravity, but a lot more loosely and containing a lot less stars, usually just a few hundred, as opposed to up to 1,000,000 in a typical globular cluster. And here, the stars are also very different. These are extremely young stars, whereas a globular cluster will have very ancient stars. But most importantly, these are usually inside the galactic plane and very often inside or very close to galactic arms. And because the majority of open clusters seem to be extremely young, it basically suggests that these objects fall apart pretty quickly. Actually, the only known open cluster that seems to be relatively old is M67, also known as the King Cobra cluster. But this one is an exception and is a bit of a mystery, and we'll actually explore this in some of the future videos. So yeah, maybe subscribe. And so anyway, with the exception of this cluster, everything else out there seems to be really young, and so the scientists believe that most of them very likely disappear because they get disrupted by various other clusters or even giant molecular clouds. But because they're so young, by basically focusing on the motion of these stars across the Milky Way, it's possible to trace back their vector velocity just to see where they might have been created. And that's essentially what the scientists behind this recent study that you can find in the description decided to do. They took a look at 272 known clusters and used the data from the Gaia telescope to try to trace back their motion. And though for many of these clusters it was a little bit difficult, for approximately 150 or about 60% of all of them, it was possible. And turns out that many of them seem to trace back their origin to a relatively similar location somewhere in the Milky Way galaxy, and specifically 3 separate locations. Here the researchers decided to name them Calendar 135, Messier 6, and Alpha Persei. So here's for example some of the members from the Messier 6 family, and as you can see quite a lot of them are actually in entirely different locations in the Milky Way galaxy, and here are some of the members from the Alpha Persei and the Calendar 135 families. And so here within about 3,500 light-years away from the Sun, 155 such clusters basically came from just 3 locations in the last 60 million years. And specifically from 3 star-forming regions. Regions that seem to be extremely active and potentially contain a lot of mass in order to produce all of these clusters. And specifically here, by looking at the trajectory between about 30 and 50 million years ago, you can actually see how all of this converges into just 3 separate locations. But we obviously have no idea what exactly these families are, and they're actually just named after the main members in each of these families. In other words, the place of origin is no longer visible and potentially no longer produces stars. But each of these families does contain quite a lot of members. The biggest one contains 82 clusters, with the other two containing 39 and 34, with all of these families containing approximately 28,000 stars. But naturally here there are some additional questions. For example, why did all of these clusters escape their home, and why they're all now in completely different locations? So basically, even though they all have common origins, why aren't they actually in the same place? And well, here the researchers worked out that they most likely got kicked out by a huge number of supernova. The supernova that then produced a kind of a bubble in the middle. And specifically, up to about 200 powerful supernova would have to occur over millions of years in order to produce enough energy to dislodge and to kick out all of these stars. And so all of these powerful explosions most likely left a giant bubble in the middle of interstellar medium. And the thing is, we know these superbubbles do exist, and technically the solar system is currently inside one of them as well. And we've actually discussed this particular discovery in one of the videos right there. And so these giant bubbles that seem to be all over the Milky Way are very likely the result of these numerous supernova from the same location that in this case formed an enormous bubble at least 3,000 light years across as well. And inside of these massive bubbles, we essentially just have lower density of gas compared to everywhere else. This massive bubble is most likely directly connected to all of these star clusters within about 3,500 light years away from the Sun. And assuming that all of this is correct, all of these massive supernova would most likely leave a lot of traces in the sediment on planet Earth, which we've actually discussed in one of the recent videos you can find in the description below. And by itself, this is a really intriguing discovery. It basically, once again, allows us to study the history of the Milky Way galaxy, and specifically the evolution of the structure of the Milky Way, by looking at the motion of various star clusters in the last 60 million years. And since a lot of these open clusters are essentially producing brand new stars that are eventually going to go on their own merry way once the cluster falls apart, in some sense this also tells us a little bit more about the history of the solar system and how most stars very likely start their existence. And that's because most of these star clusters are eventually going to fall apart, becoming what's known as the stellar association, and even these structures will eventually fall apart, with each star acquiring their own motion. But when it comes to clusters, there are obviously a lot more mysteries. For example, globular clusters are as mysterious as they get, but even other clusters, such as the unusual superstar clusters, such as the one you see right here known as Westerlund 1, seem to be different from everything else and seem to hide their own secrets as well. Not to mention that scientists have even discovered some unusual clusters in the Andromeda galaxy that seem to be basically something in between. These actually have been referred to as the hybrid clusters, or sometimes as extended globular clusters, which have not been seen anywhere else. And some other galaxies contain more mysteries. For example, faint fuzzies. Bizarre faint formations that seem to represent diffuse clusters, but only discovered in various lenticular galaxies, such as NGC 1023 you see right here. And so yeah, there are still so many mysteries about various clusters, and naturally about star formation and the evolution of galaxies. Which means that we'll come back and talk more about this in some of the future videos. On that note, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.